In this lesson, we're going to start looking at inequalities. Now, up until now, everything that we have worked with has been an equation. They've always had equal signs in them. And now we're going to start looking at things that are inequalities. And a lot of things that we talk about in the real world actually are inequalities. For example, if you're going to take a job, you might be okay making exactly $5 an hour, but you'd be much happier if you made something more than $5 an hour. It doesn't matter if it's $5.50 or $6 or $7. More than is really more important than exactly $5. And so inequalities actually describe a lot of the things that we talk about in the real world. So to start with, when we say an inequality, what we mean is that we've got two things where one side is bigger or smaller than the other one. Okay, so it's a relationship where one expression is larger or smaller than the other one, as opposed to being equal to each other. And when we solve an inequality, we end up with a solution set. And what we mean by a solution set is it's a whole set of numbers that satisfy the inequality. It's not just one answer. When we say x is greater than 5, there's lots of different answers for that. It could be 6, it could be 7, it could be 50, it could be 1,000,000. But there's lots of numbers that are greater than 5. And so it's a whole solution set as opposed to being just a solution. And since there's a whole solution set, we're going to show our answers a little bit differently than what we would have done in the past. Now, first of all, here are our 4 inequality signs, and you know them for the most part by the first line underneath each one of these. Less than or equal to, greater than, or greater than or equal to. But there's some other phrases that you can use to describe those same expressions. For example, less than can also be described with the words fewer than. When we say there were less than 5 people there, we can also say there were fewer than 5 people there. That's expressing that same idea. This sign that's less than or equal to, sometimes we also use the phrase at most or no more than or a maximum of. There's a maximum number of people that can be on a school bus. If you look at the side, maybe like 60 or something, and it will say maximum number of riders is 60. That means that the number of riders has to be less than or equal to 60, or it can be at most 60, or it can be no more than 60, or it can be a maximum of 60. And so those are all phrases that reflect this idea of less than or equal to. And then we've got ones that go with greater than and greater than or equal to that are kind of opposite of the ones that we see for less than or equal to. So copy these into your notes here so you've got these to look back at later. All right, so when we have these inequalities, like we said, there's a solution set to these. And so we're going to have to express more than just one single answer. We're going to have to express a lot of answers. And so the way we do this is we a lot of times graph these on a number line. Instead of it just being a single answer, it's all the numbers to one side or another of a certain value. And so first of all, when we graph an inequality, the first thing we want to do is find the number that we're going to start at. And so if it's an inequality, a lot of times that's the number that's in the inequality. We're going to find that number on the number line. And then we want to check and see what type of inequality we're using. Is it less than or equal to, greater than or equal to? At the number that we found, we're going to put a circle. Now that may be a solid circle or it may be an open circle. It's going to be a solid circle if you have less than or equal to or greater than or equal to. If it's one of our equal to inequalities, then you use a solid circle at that point. If it's not, you use an open circle. So one way to think about that is when you look at this inequality, it's got a solid line underneath it. It's got a solid foundation. And so if there's a solid line underneath this, you're going to go with a solid circle. If it's wide open underneath here, if there's nothing there, then you use an open circle. Okay, once you have got the right type of circle, then you just have to decide which direction you're going to go. So draw your arrow whichever direction you need to go, and then make sure you put an arrow on it. And so let's practice drawing a couple of number lines here. So the first one we're going to do is x is greater than 5. And so the first thing we want to do is find the number 5. Now if the 0 is not marked on your number line, go ahead and find a spot and put 0 on your number line. Okay, so based on where 0 is at, we now need to find 5. So here's 0. So positive numbers are to the right. So 1, 2, 3, 4, 5. This is 5. Okay, are we going to use an open circle or a closed circle at 5? Okay, since it's wide open underneath, you want to put an open circle right here at 5. Okay, now we want numbers that are bigger than 5. We want numbers that are going to make this true. So what's a number I could put in here for x that would make this true? Okay, 6 would make this true. 7 would make this true. And so where's 6 and 7 at? Well, they're right over here. And so my arrow on this number line needs to be headed in that direction. And so I want to make sure that you get a nice, obvious arrow go in the direction it needs to go there. So that would be the number line for x is greater than 5. And so basically anything that this red line touches, and notice it's got an arrow, which means it keeps on going that way, anything this red line touches is a solution to that inequality. So 6 is a solution, 7 is a solution, but numbers like 3 and 2 are not. Okay, let's graph this next inequality. X is less than or equal to negative 3. Okay, so first of all, find negative 3 and put the correct type of circle there. Okay, so at negative 3, that's 0, this is negative 3, you should put a solid circle. And again, you want to overemphasize that circle there just so everybody can be clear where it's at. Okay, now we want less than or equal to negative 3. So again, what numbers would make that true? Okay, numbers like negative 4 and negative 5 are less than negative 3. And so here's negative 4 and here's negative 5. And so our number line needs to be going in that direction. And so again, make sure it's really clear that that's the direction your number line is going from that circle. And so negative 4 and negative 5 are being touched by that number line. Numbers like 0 and 5 are not. Now sometimes the solution to an inequality is just that clear. When it says x is greater than 5, we know exactly what to graph. Sometimes, though, it's hidden a little bit, and we have to do a little bit of work to figure out what the answer is. So number 1 is here is an example of that. Okay, it doesn't say x is less than negative 3. It says x minus 7 is less than negative 3. And so we're going to solve this inequality just like we would solve an equation. So just for a minute here, let's say that instead of it being x minus 7 equals negative, or less than negative 3, let's say it said equal negative 3. What would you do to solve that inequality? Well, you would probably draw a line and you would add 7 to this side. Okay, you'd add 7 and you would end up with x on this side and you'd end up with positive 4 on this side. And we'd still have an equal sign right there in the middle. Well, we're going to do the same thing when we solve this inequality. Okay, we want to get the x by itself. So this minus 7 that's over here, we're going to bring it to this side and make it a plus 7. So now x is all by itself over here. Negative 3 plus 7 is 4. And that inequality sign, just like the equal sign came straight down, this inequality sign comes straight down. So we end up with x is less than 4. Okay, so go ahead and graph that on your number line. Okay, so you should have an open circle at 4. And we want less than, so we want numbers like 3 and 2 and 0. And so our number line should be going this direction for less than. So notice whenever we have our inequality written here, that if you were to make an arrow out of that inequality sign, like this is a less than sign, if you were to make an arrow out of that, it's pointing which direction your arrow goes. Now that's true as long as the variable is on the left side of the equation or the inequality. That's always going to be true. So, okay, so here we have n plus 10 is greater than or equal to 5. Okay, so go ahead and solve that. What do you get for your answer? Okay, so you should have subtracted 10 and gotten n is greater than or equal to negative 5. So find negative 5 on your number line and go ahead and graph that. Okay, what type of circle would you use? Okay, you should have used a closed circle. So here's negative 5. You want a closed circle. You want greater than or equal to. So which direction do you head? To the right or to the left? Okay, you should have said that you were going to go to the right. And so that's what that answer is. And again, if you look at that inequality, make an arrow out of that right to the center and it's pointing to the right, so that's the direction we end up going. Okay, let's go ahead and solve this next one. We got 6 is greater than or equal to z minus 3. Okay, so go ahead and solve that inequality. What do you get? Okay, so first of all, we would add 3, and so we get 9 on this side. Keep the inequality sign the same, and we get z. So we have 9 is greater than or equal to z. Now that's backwards. We always want to have the z, or we always want to put the variable over here on the left side. So since 9 is greater than or equal to z, we want to switch this around. So we want to get the z on this side and the 9 on this side. Now, go back to your elementary days. Which side is the shark going to eat here, the 9 or the z? Okay, the shark or the fish is eating the 9. And so when we copy it down over here, we still want that to be true. We still want this fish to eat the 9. So whenever we rearrange this, it flips the inequality sign around whenever we change it from one side to the other. So we want to graph z is less than or equal to 9. So find 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, open circle or closed circle right there. Okay, closed circle because it's got a solid foundation, so you need to have a solid circle. And we want less than, and if you made an arrow out of that, it's pointing to the left. And so our number line needs to go this way. And so that's the solution. And if we want to check that, pick a number on our number line, make sure we've got the right answer. Okay, so 0 is part of our solution here. If you put 0 in, 6 is greater than or equal to 0 minus 3. And so we know we do have the right answer there. Okay, try number 4 on your own and go ahead and rearrange it so k ends up on the left side. Okay, so it starts off as 8 is greater than k plus 6. So the first thing we do to solve it is we subtract 6. And so that gives you 2 is greater than k. And so when we rewrite it, it should be k is less than 2. Okay, we didn't do anything different. We just changed it from left to right. The inequality sign is still telling you the same thing. It's still telling you that 2 is bigger than k. Okay, so on your number line, here's 2. And go ahead and draw your graph. So you hit an open circle at 2, and we want less than 2. It should be pointing, make an arrow out of that. It's pointing to the left. And so your line here needs to go to the left. All right, one more for you to try. So j minus 2 is less than or equal to negative 2. Go ahead and solve that and graph it and then check your work. All right, so you should have added 2, just like solving an equation. So you end up with j on this side. Inequality sign comes straight down. Negative 2 plus 2 is 0. So we want j is less than or equal to 0. So this time at 0, we want a solid circle. And we want it shaded in less than. So we want to go to the left. And so if you want to check your answer here, pick a number on this number line. So we'll just pick, like, say, negative 6. Negative 6 minus 2, that's negative 8. Negative 8 is less than or equal to negative 2. And so we know we've got this going the right direction because when we plugged some random number in over here, it actually works. Okay, so you now should be able to solve any of these inequalities by just adding and subtracting things, and you should also be able to graph an inequality like this on a number line.